Alright, Bismillahirrahmanirrahim. Assalamualaikum and good morning. So last week you have learned about the CLO1, which was about the job that petroleum geochemists usually did in solving the problem that occur in explorations and exploitations of petroleum. So I think by now you should be able to explain and describe all the scope of work as a petroleum geochemist. Alright, now we move on to the CLO2 for this course, which from this week until approximately week 5 or 6, I hope everyone should be able to understand the petroleum system and discuss about the various elements and processes that control the volume of crude oil and natural gas that available in the entrapment. So the topic that you will learn are generally petroleum generations, which will cover on how the oil and gas form, and also petroleum migrations and accumulations. Alright, so to be specific, what you are going to learn for the CLO2 are on the characteristic of petroleum and also product of the petroleum, theory of petroleum generations, the mechanism on how hydrocarbon form in both natural way and generated way, and also the mechanism on the formations of both hydrocarbon and non-hydrocarbon. Alright, again, the purpose you need to learn all these things is because you will be among the petroleum geologists as a petroleum geochemist, that your job scope will support the decisions of drilling the petroleum prospect and solve any completion problem that occur in the oil field during the production process, as well as evaluating the new prospect for petroleum explorations. Alright, before we go very deep, by right you know what is it petroleum all about, isn't it? So I believe that you have learned and know about the term petroleum itself in general. Alright, so in general, the definitions that usually people in the industry use is petroleum is actually a form of bitumen composed principally of hydrocarbon, which contain carbon and hydrogen atoms, and also there will be existing as a gas or gaseous state in its natural reservoir. But in the petroleum geochemistry, you can use term as a naturally occurring liquid, gas, semi-solid, or solid mixture of hydrocarbon and non-hydrocarbon molecules. While in N accumulations, you might find any of these three forms of petroleum, maybe all or maybe any one of these, that are natural gas, which does not condense at STP. So STP here stand for standard temperature and pressure. Second, you may found there would be condensate, which it is a gases at reservoir, but it condenses to form liquid when it reach to the surface. And third, you may find, of course, most of the entrapment, there will be a crude oil column, that it is a liquid part of the petroleum. So this is the example of the simplest hydrocarbon, which has one carbon atom and 4 hydrogen atoms. So this is what we call methane. So methane is an example of natural gas that behave as the smallest hydrocarbon and the most common and abundantly found in all sedimentary basins in the world. So the structure above the methane that consists of 4 carbon atoms and 8 hydrogen atoms with a straight change, alright, that bond all the atoms. This is an example of butane. Alright, a model of petroleum that have been proposed by Waihi IA in 1999, in which he had suggested a more specific term for petroleum to be used in the industry, and this commonly used among the geochemists worldwide. So to be specific, petroleum is a colloidal solution of resin and aspartame in aromatic and saturates. So aspartames here refer to the solute or solid material that dissolve in solutions. Resin as a dispersant in which it distributed loosely in the aromatic solvent. Aromatic here is a liquid substance that is capable to dissolve the aspartines and resins, and saturates here refers to the non-solvent of hydrocarbon. Alright, so the petroleum is usually composed almost the entire elements of hydrogens and carbon, which it is in ratio of about 1.85 hydrogen to 1 carbon atom in the crude oil. The petroleum also has the minor elements, which are nitrogen, sulfur, oxygen compound that constitute less than 3% of most petroleum. And there are also the presence of traces of heavy metals such as vanadium and nickel in the crude oil. So this table here shows the comparisons of the elemental compositions of gas, oil, asphalt, coal, and dispersed organic matter. Here refers to the corrosion in the sedimentary rock from average worldwide record. So as we going across from gas to corrosion, there are a marked decrease in hydrogen and a corresponding increase in sulfur, nitrogen, and oxygen with relative to the carbon content. You have to remember that the quality of petroleum generated is determined mainly by the hydrogen content of the corrosions. If you find that corrosion has about 7 to 10% of hydrogen content, meaning that it will generate far more oil and gas. So corrosion here refers to the insoluble organic matter in organic solvent. So among of these elements, hydrogen is much lighter elements. Therefore, oils that contain high amount of hydrogen will have lower in specific gravities. Whereas if the oil contains high amount of nitrogen, sulfur and oxygen compounds, they will give the oil a higher in specific gravity because these elements are heavier than carbon and hydrogens. Okay, clear. So you have to remember in this case, right, to measure the specific gravities of petroleum, which refers to the API gravity, that stands for American Petroleum Institute, right? They measure the density of oil using a hydrometer that having a scale developed by the API. So it is used to determine the market price of the crude oil. So remember, for the API gravity, if you have light oil, it means that the API gravity values is more than 31 API. If you have found medium oil, so the range of API gravity would be 22 to 31 API. If it is heavy oil, so the API values will be 10 to 22 API. And if it is extra heavy oil, so it will be less than 10 API gravity. But if you find there is condensate in the entrapment, the API gravity should be more than 50 API. So if you find the API increase, it means that the specific gravity decreases. Okay. Alright. So the term hydrocarbon itself refers to the combinations of elements carbon and hydrogens. So both of these elements are vary in size and type of molecule in the crude oil, which will cause the differences in chemical and physical properties of the petroleum. So this crude oil would be later separated by distillation process in the refining tower that will yield the product from the smallest to the largest size of molecule and type. Alright, so we go first to the molecular size variations in petroleum. So as I mentioned earlier, the smallest molecule in petroleum is methane with a molecular weight of 16, and it has been found abundance in like gasoline, while the largest molecules is the alphatane with the molecular weight in the tens of thousands, which will produce residue in or during distillation process. So between of these two extreme molecular size in petroleum, there are thousands of compounds that having simple to very complex structure, and the product form will have high molecular weight of hydrocarbon that range from heavy gasoline to heavy gas oil. So meaning that as the molecular size increases, the individual members will changes from gases to liquid to solid. Alright, part of the meaning of the hydrocarbon, it is actually form a homolog series, that is refers to families of molecules whose members have similar properties but differ in size by the CH2 groups. So this causes the petroleum to have a variations in molecular types, and these hydrocarbon molecules occur in different structural forms. So we have here the hydrocarbon from alkanes, cycloalkanes, alkenes, and arenes. And the non-hydrocarbon compounds would be the aliphatic, the nitrogen, sulfur, and oxygen compound. So we go to each of these types of hydrocarbon. So first, alkenes are the open chain molecules with single bonds between carbon atoms. So the N number here refers to the normal alkenes. So the N number also usually fewer than AT. Alright, so people in the industry usually prefer to use the term paraffins, saturates and aliphatics. That is more familiar among the petroleum geologists and engineer. While during your high school, you usually use alkenes as the terms in chemistry. So these type of hydrocarbons are the second most common compound that has been found in the crude oil, in which these paraffins dominate the gasoline fractions in the crude oil and become the oldest hydrocarbons that mostly occur in deeply buried reservoir. So it has two types which are called normal paraffin or N-paraffins. So the normal paraffin here form a homolog series, while the N-paraffin here containing different kinds of branching isomer that have different compounds with same molecular formula and form homologs, that is the member of the homologous series. So you can here see the butane form an isomer of isobutane, while if you have hexane as the normal paraffin, it can form an isomer, that is 3-methylhexane. Alright, next, the second type of hydrocarbon is cycloalkenes with the molecular structure CnH2n. So in the industry, they usually call this type as naphtene, cycloparaffin, and saturates. So it is an alkene rings that form by joining the carbon atoms in a ring and are most common molecular structure in petroleum, in which it has been found almost 50% in the crude oil itself. So these are the two examples of the cycloalkenes, that is methyl cyclopentane, right, and methyl cyclohexane. Next is alkenes with the molecular structure CnH2n-2. So the common terms in the industry is olefin, which contain one or more double bonds. So these are originated from plants and animals. But it has been found uncommon in crude oil because they are readily reduced to paraffin with hydrogen, but they form in refinery process as the major starting materials for petrochemicals. Alright, the fourth type of hydrocarbon here is arenes with the molecular structure CnH2n-6. So in the industry, they usually call as aromatic or saturated hydrocarbon. So it is the only one type of hydrocarbon that has pleasant smelling compounds and contain at least one benzene ring. So it has high boiling point. That means we need high temperature to boil this substance. So because of that, this type of hydrocarbon or this aromatic, it usually will appear as a larger system of condensed rings and found rarely amount in the crude oil with less than 15% of the total crude oil. So the example of aromatic here, you can see toluene, benzene, and polycyclic aromatic. Alright, the last compound that you may found in the petroleum is the non-hydrocarbon that consists of this element: nitrogen, sulfur, and oxygen. So in the industry, right, they usually call this compound as aliphatic, and it occurred or it preserved in the petroleum with a small amount, and it contained, right, this major component, right, in the crude oil. Like for example, sulfur, it comes from thiols, sulfides, and thiophenes, while nitrogen, the major compounds like pyrols, iodols, and oxygen you may find in change or ring acid. Alright, for the petroleum product, well, distillation is the principal method for separating the crude oil into useful products. So this is usually called as refinery tower, that is equivalent to a series of individual distillation flasks in which the distillate from the first flask is condensed in the second flask and redistillate to produce a distillate for the third flask. So instead of the flask, the tower has condensation plates in which each of the overlying chamber in the tower condenses successively lighter and smaller molecule until only the light gasoline escape from the top. So at the bottom of the tower are those molecules that are so large and heavy which they cannot penetrate as gases through the first plate, so they end up in the residue. So these are the product of petroleum. You may read through all these products. So in general, the product are light gasoline, heavy gasoline, kerosene, diesel fuel, lubricant or heavy gas oil, and residue. So in conclusion, the high API gravity of crude oil usually will have as a high gasoline and low in residue content, whereas low API gravity oils will consist of low in gasoline and high in residue, because high gravity means low viscosity. Thus, small molecules are easy to be condensed and form like hydrocarbon. That is why small molecular type of hydrocarbon such as paraffin, naphthalene are mostly found in the crude oil because they are easy to migrate and accumulate in the reservoir, and they are dominant in gasoline. So you can read through all the products from the hydrocarbon and also the descriptions of each of the products. For example, light gasoline, right? It has both compound of petroleum, that is hydrocarbon gas, and also non-hydrocarbon compound or non-hydrocarbon gas. So hydrocarbon gas here refers to dry gas, that is methane, and wet gas, that is start from carbon 2 and plus. While the non-hydrocarbon gas, that are nitrogen gas, carbon dioxide gas, hydrogen sulfide gas, and helium gas. So like gasoline is preserved as the cleanest fossil fuel. Okay, you can see here LPG, LNG. So what is LPG? What is LNG? You have to find by yourself. Alright, for the heavy gasoline, start with carbon 5 to carbon 10, right? It is 10 to 40% of product that may produce from the crude oil. And if you want to increase the amount, right, you can do the cracking and polymerizations. So the cracking means from the heavier molecule, you crack and you form lighter molecule, while polymerization is from the lighter molecule, you expand it, right, to become a larger molecule. Alright, next, kerosene here is the hydrocarbon that contains 10 to 40% of aromatics and naphthalene, and it is useful for jet fuel and diesel fuel. And also it contains the non-hydrocarbon compounds that can produce the naphthenic acid and phenols. Alright, diesel fuel here with the carbon number 14 to carbon number 18, it can be used for jet fuels and diesel fuels. Okay, from heavy oil or heavy gas oil, alright, that usually composed of normal paraffin waxes. The meaning of waxes here refers to the heavier molecular compound that preserved in the heavy gas oil. Alright, so it also composed of the aspartic compound of NSO. And lastly, the residue here will consist of more than carbon 40, and it is useful as a product of furnace oil and road construction, and it is most complex because it contains larger volume of resin, aspartame, waxes, and heavy oil. And also you may find there will be condensate that will be collected in a separate separator. So the API gravity here, it could be more than 55 API gravity, and it contains saturated hydrocarbon, right, such as butane, pentane, hexanes, and it also found early in all oil producing area with the GOR gas oil ratio more than 5,000 cubic feet gas per barrel. Alright, so this is the summary of the molecular size and molecular type of hydrocarbon. So you can read through all this, right? So for the molecular type, you may find that naphthalene is the most highest hydrocarbon that has been found in the crude oil. Okay, the reasons why, because naphthalene has been found in start from kerosene, diesel fuel, heavy gas oil, lubricant oil. So that is why you find naphthalene is most abundantly occur in the oil or in the hydrocarbon products. Alright, so we have done for the petroleum characteristics and products. Alright, now we move on to the generations of petroleum. So what you will learn here are the theory of generations, how both natural and generated hydrocarbon forms, as well as how does natural gas forms, both for hydrocarbon gas and non-hydrocarbon gas. So as a petroleum geologist, right, you should be able to know where does petroleum come from. And you should be able to know how does the petroleum generates, how does petroleum migrates, and how does petroleum accumulates. So as a petroleum geochemist, these are the things that you need to know from the beginning, right? Because you are the one who will tell your company why did you conclude or why did you decided, right, on that particular area or accumulation as a prospect of petroleum. And you will be the one who make decisions to select that particular petroleum prospect to be drilled. So to make that kind of decisions and to support decisions in the team, right, you must have the idea on telling to your company on how does the petroleum generates, migrates, and accumulate as well, preserve in that prospect, and to have that kind of constructive and definite interpretations, you must know how to evaluate the petroleum system that exists in the particular sedimentary basin. So what is petroleum system? So petroleum system here refers to a system that encompasses all those geological elements and processes that are essential for commercial oil to occur in nature. So I think if you are final year, you should be able to know all the elements and processes of a petroleum system. But in this chapter, I will recap all those fundamental knowledge that you have learned before. So there are 5 elements and 4 processes which in relation to each other. So we have here source rock elements in relations to the generations of petroleums, and then we have migration path which relates to the migration process of the petroleum from the source rock to the carrier bed. And then we have the trap and reservoir rocks of the petroleum system that bring the petroleum to be accumulated in it. And we also have lastly the shale rock as the elements of petroleum system that is an element that can preserve all the oil below the ground. Okay, so you will learn each of these parameters in specific so that you can contribute for making the decisions of the selection of drilling the petroleum prospect. Alright, so there are specific mechanisms involved before petroleum being trapped in a reservoir rock. Okay, so these are a schematic petroleum system that contains the elements and also processes of the generations, migrations, accumulations, and preservations of hydrocarbon. So in general, the source rock, it has to be a rock that rich in organic matter. So you have to remember that a source rock has nothing to do with the reservoir rock that contains the oil in the oil field. So the source rock here is the rock that generated the oil and later migrated into the reservoir rock. And the source rock may be or can be tens of miles away from the oil field. Okay, so this organic matter then will be transformed to corrosion by diagenesis and compactions, and into petroleum by the heat and pressure during maturation process. So when the corrosion in the source rock become matured during catagenesis process, the oil and gas will undergo the primary migration, which the oil and gas will migrate from the source rock to the carrier bed or migration path, and later will allow the hydrocarbon to move from the trap that here, for example, the fork, and later to move to the trap or the reservoir rock by the secondary migrations. So the trap here, right, in this case, is a structural traps of reverse fault. And the trap here also contains the anticlined, right, that will later prevent the oil and gas from going up or leak, as well as this seal rock will keep the petroleum below ground. So this is where the accumulations processes and preservation process of the hydrocarbon will occur. So at the same time, an adequate reservoir beds from which the petroleum can be extracted will preserve these accumulations with the help of the sea rock. So you have to remember from the ClO1, right? And accumulations of oil may be derived from different source rock or may have differ in the contributions of the oil from multiple source rock. So it means that if the oil derived from different source rocks, it will have different in the compositions and properties. So since the oil from different source rock have different times of generations and different times of migration processes and path, right? The presence of more than one source rock in a basin may cause difference in the reservoir compartments to fill with the different mixes of oil from the respective source rocks. If the oil derived from the same source rock, but it contains or it generated in different level of maturity, it will cause also different in the composition and properties of the oil in the entrapment, because different level of maturity of hydrocarbon generations will expel the hydrocarbon at different time. Sorry. So meaning that if the generations of petroleum occur at different level of maturity, so it will expel from the source rock to the migration path at different timing as well. So those primary batch of oil that may arrive to the reservoir rock and subjected to longer time period of alterations will tend to alter the properties of the original properties, while the second batch of the petroleum that later may reach to the reservoir rock will tend to altered differently from the parent oil. So in the reservoir, you may find there will be different oil properties. Although different oil properties in one oil column. So there will be degraded oil at the bottom that represents the primary charge or the first batch of oil that arrive in the accumulations, while the top column of the oil will represent or will consist of non-degraded oil that represents the second batch of the oil. So within an accumulation, you may find that there will be mixes of different oil compositions and properties. Okay, so to make these processes from the generations, migrations, accumulations, and preservations in relations to the elements of the petroleum system, there must be proper timing of events from the generations until the preservations. So at the end, you have to form an event chart that representing all the petroleum systems and elements of a basin. So from there, you can see when is the elements formed, and also you may see when is the petroleum starts to generate and migrates, and how long is the petroleum will be generated and migrated. So you may also found or seen that when is the critical moment of the petroleum generations, migrations, and preservations. So the critical moment here refers to the moment stand for the 50% of the oils has been generated, and the critical here refers to the trap and the reservoir rock has been formed in the basins. So once these two elements in the petroleum systems has been there, so you may put this remark of critical moment in the event chart. Okay, clear? Okay, now we go for the details in the generations of petroleum. So we have here two theories that have been proposed by the scientists in order to tell where does the petroleum come from. So first, they thought the petroleum generates through the abiogenetic theory, in which the hydrocarbons found in petroleum can be generated from the mantle by the abiogenetic processes, and the petroleum then migrate out from the mantle into the crust until they escape to the surface if there no traps or trapped in the reservoir by the cap rock. Second theory here refers to the biogenic theory, which this theory is more reliable than abiogenetic theory and mainly agreed by the scientists worldwide because of some reasons. Later I will explain in the next slide. So this theory proposes that petroleum is generated by the effects of heat and pressure on the organic remains of living organic matter that occur in the subsurface. So both of these theories comes with the evidences on why the scientists propose these theories in order to tell the generations of petroleum. As well, there are limitations on why a few scientists decline to accept the theories, while most will accept these theories. Alright, for the abergenate theories, there are four evidences to support the evolutions of petroleum through abergenate theories. So first, scientists said that there are presence of methane in the meteorites and other extraterrestrial bodies that ultimately has same source from the mantle of the earth. And second, they say that all compounds of petroleum can be prepared and synthesized by inorganic methods. However, in this case, oil cannot be synthesized. Third, methane can polymerize to higher homologues by applying high temperature and pressure. That's similar to mantle pressures and temperature. And lastly, there found an unusual deposit in the granitic rocks of Vietnam that is containing petroleum, because these unusual deposits of petroleum usually the petroleum usually form from the sedimentary rock, but in this case they said unusual deposit because this petroleum form in the granitic rocks. However, there are limitations that scientists believe and limited the acceptance of these abergenate theories. So first, as I mentioned earlier, although they found the presence of methane in the meteorite crater, such as in Swilden, Siljan, but after they drill, they didn't find any hydrocarbon accumulations in the crater. So therefore, they concluded that this theory is unpredictable. Next, this theory does not accept biomarker and cannot explain on the presence of porphyrin in the oil and gas. So porphyrin here is one type of oil compounds that source from the chlorophyll that found in plants, and this suggesting of the organic input. Next, this theory cannot explain the optical rotations that derive from the product of hydrocarbon. And this optical rotation actually occurred within the bond of hydrocarbon compound when you examine the oil using an oil immersion objective for determined maturity interpretations. So because of this, scientists decline or did not accept these theories. And lastly, this theory do not support the presence of average compositions of carbon isotopes in the petroleum. So isotope here refers to the term which compound has the same atomic number but different in mass number. For example, if you have for example carbon atom, right, we have carbon 12, carbon 13 and carbon 14 that usually been used to know the depositional environment. Okay, like for example, if you study on the carbon 12 and 13, right, it can define the depositional environment, while if you use carbon 14, it is for the age dating of any fossils or any rock type. Alright, so this is the unusual deposit that has been found in the granitic rocks of Vietnam. So you may see that here most of the oil occur along the fault and joints that form in the granite. Alright, so that is the first theory of abiogenetic theory. Okay, next, biogenic theories. So we have 6 evidences that support and make this theory more reliable than the abiogenec theories. So we have here first, both organic matter and petroleum have made of dominantly carbon and hydrogen atom, and further both of them also have nitrogen. Okay, so here, meaning that they conduct the studies of the oil and they conduct also the source rock. So once they make an analysis, what we call here as the elemental analysis for both oil and the source rock, right? They found that both contained dominantly carbon and hydrogen atoms. So the scientists were confident that the petroleum were generated from the source rock. Meanwhile, nitrogen also found nearly in all petroleum. That is another direct indications of origins of petroleum. Right, so nitrogen actually is an essential component of amino acids, that is the hydrolyzed protein of living matter. Even we human also have a amino acid in our body. Okay, for the second evidence, right, there are presence of optical activity in petroleum, which the optical activity in petroleum here meant for the power to rotate the plane of polarizations of a polarized light. And this is a property of most petroleum, and it is known to occur in oils of inorganic origin or in inorganic substance or minerals. So next, right, there are many crude oils that have been found to contain porphyrin pigment in asphalt fractions of oil. And also porphyrin is an essential presence of living organism. So this is suggesting of a direct evidence of organic origins of petroleum. Also, there are existing of biomarker in petroleum that suggests the origin of the organic compound whose the carbon structure can be traced back to living organism. So this is what we call biological markers. So some example of biological markers that you have learned in CL01 is the pristine, phytane, olinane, tryptophan, steranes, right? So this is all related to the marine, terrestrial, or lacustrine environment, or that is indirectly related to the organism, living organism in that kind of environment. So next we have the similarity of odd even periodicity between petroleum paraffins and living organism, which indicates the origins of that particular petroleum accumulations. For example, the plant that can be synthesized almost exclusively contain paraffin with odd number of carbon atom. Okay, in the change that ranging from carbon 25 to carbon 37 in variety of plants. So if you have a marine plants, right, it can be synthesized to smaller odd carbon change length of carbon 15, carbon 16, carbon 19, and carbon 21. It's okay, you will learn here, or you will learn this carbon number or carbon compound in ClO3. So next, the six evidence in supporting the petroleum generations from organic material is by the presence of polymorph material or organism of the petroleum itself. So Palynomorphia refers to the presence of fossil pollens or spore from flowering plants that usually found in swamp or in a closed system of a lake. Alright, so although the biogenic theory has more evidences than the abiogenic theories, but it does also has limitations. So we have here the limitation first is it is not possible to generate long chain hydrocarbon by polymerizations at low temperature, low pressure of natural conditions because there is a constant increase of every increase in CH2 unit. Alright, next, the average concentrations of the hydrogen in proportion to carbon is less in the organic matter than in the petroleum. So therefore, sometimes the interpretation, right, between the relations of the oil compound and also source rock compound, it does not match. So this is the most cases that are being defined by the scientists. So because of that, they said that sometimes, right, this organic matter or this oil, it does not originate from this organic matter. Okay. Alright, the last limitation is the presence of helium in some gases that cannot explain by the organic theories. So in this case, right, helium is a form of elements that originated from radioactive elements that has been generated basically from igneous body of mantle derivations, and it is not from the organic matter. So if and it has been usually observed, right, and appear in gamma ray. So if let's say you found there's a high helium elements, right, in the source rock, this will actually tells you the source rock may reach in the radioactive elements, and the source rock may be found or the the granitic rock may be found nearby, deposited to the source rock. Okay, right, so up to this point, right, these are the summary which from both theories, right, all the geochemists or scientists accept the biogenic theories because it has more evidences than the limitations. So as summary, petroleum is originated from a source rock that rich in organic matter in the sediment, and then it matured by the temperature and pressure at the greater depth in the sedimentary basin, and finally it formed oil and gas in a reservoir rock by the sea rock that help in preserving the petroleum entrapment. Alright, as I mentioned in the previous lecture, source rock is the first element in the petroleum system that a petroleum geochemist need essentially to evaluate and characterize it for clarifying from where does the petroleum is coming from. Okay, so the petroleum source rock here refers to any rock that has the capacity to generate and expel enough hydrocarbon to form an accumulation of commercial oil and gas. So in a sense, practically all rocks that contain high organic matter is assumed to form some hydrocarbons. So part of the definitions of source rock, there are two categories of source rocks. So first, we call source rock as a potential source rock if the source rock is still immature, to call it as a source of emitted petroleum in its natural setting. But this kind of source rock is assumed to form a significant quantity of commercial oil and gas when it matured. So for a source rock to be a potential source rock, the source rock must has a minimum of total organic carbon content of 0.5 weight percentage, or it can be determined by the elements of hydrogens and carbon with the ratio of 0.5. Alright, second category of petroleum source rock, right, is an effective source rock. So this is when the source rock is already matured and it has been found, already formed and expelled the hydrocarbon to a reservoir. So this source rock, it may be active, which currently still expelling the hydrocarbon, or it may be inactive due to uplift with the erosion or cooling process. Alright, there are techniques for recognizing this source rock of their quantity, quality and maturation level of the organic matter in the rock. So there are also techniques that we call oil source correlations or oil correlations that scientists use to establish a correlation between a particular source rock that has yield oil to a particular reservoir. Okay, so basically the relative ability of a source rock to generate petroleum is defined by its total organic carbon content value for the quantity and high or low in hydrogen content for the quality, and whether or not the source rock has generated petroleum is defined by its states of maturations by immature, mature or post-mature with respect to the oil. Alright, so source rock usually is characterized by a fine-grained sedimentary rock that deposited in an oxic environment with high TOC and rich in hydrogens. Okay, the reasons why most of the source rock has been characterized or has been defined as a fine sedimentary rock, because the finer the grain size of a source rock, the higher the organic matter will be preserved in the sediment. Okay, if we back to the fundamental of geology, for a fine sedimentary rock to form, it has to be related to the environment. So a fine-grained sedimentary rock usually will form in a calm environment that will has a less current and turbidity in the water column, which consequently has low intensity of the oxygen supply in the water. So because of the low supply of oxygen content in the water, the biological productivity will also become low, and the chemical degradations of that organic matter preservations will be also become low. So meaning that the preservations of the organic matter generally will increase from the high energy to low energy sediments or low energy environments in anosmic environment. So the best example of source rock is coming from shale, with 60% of petroleum worldwide have been generated and expelled from this type of rock. Okay, why does this shale has been the common petroleum source rock that found in the worldwide? Because this is the most common cemetery rock that has been found in cemetery basin worldwide. Okay, so if you can see here, right, there are three colors of the shale. We have here red, yellow, and black. So which one of these shale do you think will generate oil and gas? So basically, the one that appear black will usually contain high organic matter. Okay, this is a common screening tools that geologists or geochemists will identify whether a rock, whether a shale, right, composed of high organic matter content or not in the field. So although that those rocks that appear black, okay, will usually contain high of organic matter content, but this is only a rough observations and not always be corrected. So there should be screening tools in the laboratory that can support your decisions or your interpretation in the field. So basically, to know the organic matter richness, right, we normally will conduct the total organic carbon content analysis in the laboratory. Okay, so why don't you choose red color instead of a black color? All right, to know whether the shale can be generated oil or gas. Okay, basically red color here refers to the or meaning that the organic matter has been destroyed by the oxidation process. So you have to remember that organic matter has abundance of hydrogen molecules that are coming from the atmosphere and other reactions. So if there is oxidations, meaning that it will reduce the quantity of the hydrogen in the rock itself. And you have to remember that the quantity of the petroleum generations is depending on the hydrogen quantity in the corrosions of the organic matter. So because of the oxidation process, right, the hydrogen content will be reducing. So this is the example of a good source rock, right? That is Marcellus Shales in USA, and it is a famous and one of a giant field that has produced the shale gas. So you can see here, the shale is almost black. Alright, if a source rock that has a very high inorganic matter and rich in hydrogens, right? If you burn it in the if you fire it out, it can burn. For example, this Kimmeridge oil shale, and if you put it the sample in a closed system or in a closed container, right, For example, in these conditions, right, the shell can form their initial product of oil and water upon distillation. Alright, so basically you have to remember that the relative ability of a source rock to generate petroleum is defined by its quantity of the organic matter preservations in the rock, and also whether the high or low in hydrogen content for the quality. Alright, so if the source rock matured, right, it has the capacity to generate petroleum with the respect to the oil generation. Okay, moving on. Basically, if a fossil is deposited in sediment, whether early depositions or during or after depositions, that fossil will usually undergo alterations by diagenetic processes. So, this is also happened to the organic matter that was preserved in the sediment. So, this organic matter will undergo a diagenesis process before it can generate the petroleum in the source rock. So, in general, the origin of petroleum follows the two pathways from the living material. So the first origins of petroleum is on the left side, which around 10 to 20% of the petroleum is formed directly from the hydrocarbon synthesized by the living organisms or form their molecules, which are readily converted to the hydrocarbons. So in this case, okay, the accumulations here refers to the free hydrocarbons that form from the dead living organisms. And these hydrocarbons, right, it formed by the bacterial activity and low temperature chemical reactions in the recent unconsolidated sediments. Okay, if you take these samples, right, and then you burn it, you fire it, okay, it can form its hydrocarbon easily in low temperature reactions and by the bacterial activity in its natural setting. Okay, for the second pathway here on the right, which most of the petroleum of about 80 to 90% has been formed along this way. So this generations, right, it involves the conversions of lipids, protein, carbohydrates of living material into the organic matter of the sedimentary rocks. So when this corrosion is buried deeper at a higher temperature, right, it will crack to form a bitumen that will break down further to form petroleum. So some hydrocarbons also can form directly from the corrosions. Okay, if the petroleum is buried more deeper with the increasing in temperature, right, this petroleum may change along the two pathways, right, one leading to the increasingly smaller hydrogen rich molecule, which the end product is methane, right, and the other leading to the larger hydrogen poor in molecules, which the end products are pyrobitumen or graphite. So meaning that in the second pathway, right, there are no free hydrocarbons formations until the corrosion is heated up at a high enough temperature to crack and help the corrosion to release the hydrocarbons. Okay, so we go more specific to each of these states of maturations. During diagenesis, and then the catenasis, and then the metagenesis. Okay, diagenesis here is a process of alterations of the organic matter by biological, physical, and chemical reactions without any pronounced effect of temperature. So it covers normal or standard earth temperature range that is up to 50 degree centigrade. So during diagenesis process, right, a whole series of low temperature reactions will occur, such as these four processes: decarboxylations, deaminizations, polymerizations, and reductions. So these all processes will affect the biomarker that preserve in the organic matter. So from these reactions, right, there will be some free bitumen release, which consists largely of the biomarkers such as the N-paraffin, isoprenoids, sterins, triterpenes, and also NSO compound. So most of the surface sediment basically has been found to have a high pentane hexane of the straight chain paraffins. So basically in this stage of diagenesis, right, the ratio of the hydrocarbon to non-hydrocarbon that has been found in the bitumen of the recent sediments is in the range of 1 to 10 to 1 to 20. So meaning that 1 to 10 of hydrocarbon to 1 to 20 of hydrogens, right? And the extractable bitumen, right, that was extracted from the source rock is usually will have only 5 to 50% of the TOC or total organic carbon content. Alright, so at this time there would be a conversion of organic matter to corrogens at low temperature, and it occurs in immature sedimentary phases during generations of the petroleum. Alright, so we go first to the living organisms. So there are two different living organisms that will produce later different organic matter types. So we have here two types of organic matter. First one is refractory organic matter, and second one is the labile organic matter. So you have to remember that the living organism here refers to the all living things that are formed from a few simple molecular building blocks that have changed relatively little through the geological time. So the structures formed by this basic molecule can contain widely varying amounts of carbon and hydrogen that relative to the oxygen, nitrogen, and sulfur. So the major building blocks of life are basically coming from the carbohydrates, protein, lipids, and lignin. Okay. So lipid and lignin is the refractory organic matter, while protein and carbohydrate is the labile organic matter. So lipids here, the difference between the refractory organic matter and labile organic matter is refractory organic matter is more resistant to degradations, right? While the labile organic matter has less resistance to the degradation process. Okay, so you can read through all these type of organic matters. Okay. So in summary, right, the illustrated flow diagram here shows the summary on the origins of organic matter from living organisms. So basically, right, you have the living organism, right, will first die and form the organic matter, which consists of two types. right? The refractory organic matter that come from the living organisms of lignins and lipid that are more resistant to the degradation process, right? So this will be preserved and deposited in the sediment, while later by decompactions and low temperature reactions will form corrosions in the lithified sedimentary rock. On the other hand, right, we have the labile organic matter, which is sourced from the carbohydrates and protein of the living organism and has less stability, thus has less resistance towards a degradation process, and will undergo certain mechanism of reactions that might later cause it to diminish from the sediment. Right, so the refractory organic matter that remains and preserved in the sediment later will also expose to a few reactions of biological, physical, and chemical alterations that later cause some of the uh, molecular compounds, right, that will still be preserved and continue to form corrosions or coal in the sedimentary rock, whereas some of them degraded and diminished. So this corrosion later will be used to quantify and character the source rock potential, okay, in a particular sedimentary basins of a given petroleum system. Okay. So what is corrosion? So corrosions here is actually the insoluble organic matter in organic solvent. So as I mentioned in previously, corrosion is the first step of organic transformation by the diagenetic processes after sedimentations of dead living organism. Right, so this corrosion will later converted to the bitumen by primary cracking at temperature above 50, and later will produce the oil, gas and residue during the catalgenesis. So this is the two step of corrosion transformation that has been proposed and documented by Eglert 1913. Alright, so it is evolved, right, by him conducting a laboratory experiment to investigate the maturation history of petroleum. So you can read through the statement here, right? Okay, so these are the theories, okay, or the flow or the history. How does the corrosion terms here evolve? Okay, you can read through here all this research that has been done by the previous workers. So this is how we appreciate all those contributions of these researchers to the petroleum geochemistry background. So again, corrosion is defined as insoluble organic matter in organic solvent. Okay, and these are the two theories of the corrosion formations. So you can read through all these informations, right, from these two theories, right? But basically, corrosion formations is involved in the condensation reactions. So normally we call it actually similar to the qualification processes of a coal. Okay, all right. So now we move on to the corrosion type. So in general, right, we have four corrosion types. So the one that you've seen in the slide here, right, consists of type 1. Type 2 is the mix between type 1 and type 3. Okay, so if the source rock contains high corrosion of type 1, right, it means that the source rock is rich in hydrogens and lipid, and it serves as the best oil source. Okay, while the type 2 here will be the mixing between these two inputs of the type 1 and type 3. And mainly it's a herbaceous kerogen. It's a good for both oil source and also gas source. Okay, whereas the type 3 here is mainly from wood kerogen. Okay, basically coal source rock with hydrogen pearl, and it is a good gas source. So the average DOC value of the type 1 is 2.12, which fall in good to excellent source richness of organic matter, right? While the average type 3 kerogen will has minimum of about 0.38 in TOC value, and the average for the type 2 it's fall between these values. Okay, for the kerogen type 1, right, that serve as the best oil source, you can refer to this information. So particularly type 1 deposited from the lacustrine environment. So these are the origins that consist of the algae material, amorphous organic matter, cyanobacteria, freshwater algae, and land plant resin. So the compound that mainly found in the kerogen type 1 is the cyclic and aromatic structures, right? Mainly from the proteins and lipid of living organism. Right, if the coal has kerogen type 1, basically we refer or we name this coal as alginate or bauxite. Okay, so the H by C O by C ratios normally will compose of more than 1.25 and less than 0.15 respectively, and the product that produced right by the kerogen type 1 would be oil prune source rock. Okay, next type 2 or type 2S, it's deposited or it's originated from the marine environment. Okay, has the herbaceous organic matter with the compounds mostly fluorescent. Alright, so if it's a coal, right, we can found the materials of axinite, resinite, liptinite, suberinite, sporinite, and cotinite. And basically, the coal that contain high kerogen type 2 will classify as cannel coal. Alright, the elements of H by C, O by C, basically less than 1.25 for H by C ratios and 0.03 to 0.15 for O by C ratios. And the product of the hydrocarbons, right, basically mix oil and gas. Alright, kerogen type 3 basically came or originated from terrestrial, where we can found the humid coals, right, mostly found in this kind of deposition environment. So the origin, right, it came from non-fluorescent amorphous organic matter, woody cellulose, and also lignin materials. Right, the major compound that found in the kerogen type 3 are the cyclic and aromatic structure, right, and mainly contain protein and lipid. So the coal material that has kerogen type 3, basically we name it as vitrinites, right, and it is a humid coal. So it has the lowest H by C, right, and O by C ratios. Okay, and the product is a gas prune. And lastly, we have the kerogen type 4 that is deposited in the terrestrial, right? But it has no potential of hydrocarbon. So basically, the origin of this source rock, right? Basically, it comes from the burnt forest. Okay, so if the coal the coal has a high kerogen type 4, it means that it has high in inertitic material. So basically, if you observe, right, the source rock, right, under the microscope, you may found that the organic matter is a non-fluorescing organic matter. Okay. So how do we isolate the corrosion, right? We have to conduct a laboratory corrosion isolations analysis. So these are the uh, procedure how you can isolate the corrosion. So you will learn, right, more details in the CO3. Okay, so in summary, right? So in summary, right, please bear in mind that the quantity of petroleum generated is determined mainly by the amount of the organic matter richness. In other words, the amount of the organic carbon content that preserved in the organic matter. Okay, while the quality of the source rock is mainly determined by the quantity of the hydrogen preservations. So, the best example of the geometry or depositional environments are in the stagnant lake, where this environment, right, is characterized as the anosic environment, okay, or reducing environment, which in this reduction condition, right, the hydrogen will preserve and enhance the quantity and quality of the hydrogen content in the organic matter. Okay, so remember during the diagenesis, right, under this reducing condition, this complex mixture of geo or biopolymers or monomers will undergo a whole series of low temperature biological and chemical reactions that may result in the formations of more hydrocarbon-like material through the loss of oxygen, nitrogen, and sulfur. Okay, so some of the degraded biomonomers will undergo no further reactions, but others will condense to form complex high molecular weight geopolymer, which along with undegraded biopolymer become the precursor of the oil. Okay, so this illustrated pictures is an example of a stagnant lake, right? So you may see here there are three different water column, okay, that are oxide that has more than 1.0 milliliter per liter of dissolved oxygen in water, and then we have suboxic, okay, with the 1.0 to 0.1 milliliter per liter of dissolved oxygen in water, and then we have the anosic that has less than 0.1 milliliter per liter of dissolved oxygen in water. So as we go across this table, right, you can see that there is markedly decrease in the TOC and H by C ratios values from the anosic to oxic environment. Okay, so you can see that anosic or reducing environment shows the highest value and serve as the best region that produce the oil. Okay, why? Because as we going deeper, there will be limited oxygen supply for the organism to stay alive. Thus, there will be less nutrient and only reducing bacteria can survive in these conditions as they are active only in the absence of oxygens. meaning that there are no other living organism, right, will be alive in this kind of environment. Okay, additionally, there would be a very low water current that cause the sediment deposited are in a fine grain, and sometimes you can see there would be laminations, right, that in that lamination usually will be preserving high organic debris in the sediments. So this condition, right, will enhance the hydrogen content preservation in the corrosion itself. Okay, so this sediment from the anosemic environment, right, it will produce strongly the oil prune. Okay, so meanwhile in the suboceanic environment, right, there will be a continual decrease in oxygen towards the basin floor, and as a consequence, right, there will be an exponential decrease in the species diversity of all the benthic organisms. So in this environment, basically, right, you only will found the micro and macro burrowed organism that also has a poorly classified organism, okay, in this kind of environment. So mostly you will find the soft bodies of worm and benthic metazoan. Alright, so these conditions, right, of suboceanic environment will tend to produce moderately oil prone and gas prone. So it means that it's in a moderate amount of hydrocarbon generations. Okay, for the oxic environment, right, so those sediments that we produce would be the best gas source to non-source. So in this environment, right, there will be diverse benthic assemblages of calcareous fossil, okay, such as zooplankton, mollusks, bivalve, because this organism, right, to stay to survive, right, they need higher oxygen supply. So oxy has high oxygen supply with more than 1.0 liter per liter. So because of the presence of this organism, it's higher, all right, so it will create high biological activity, and thus it will cause the higher biotubation in the sediment. So because of that, right, the preservations of the organic matter will be disturbed by the activity, and it will later preserve in a low quantity. Okay, alright, part of evaluating the source rock for hydrocarbon potential investigations, geochemists will use indications of biomarker that exist in the crude oil or in the source rock to validate on the TOC and H by C ratio, and from there they will be integrated data on the integrated interpretations on the available data. So what is biomarker here? It refers to the micro fossils that has that has less than 30 nanometer in diameter. So it's a fossil molecular that has specific carbon structure or skeleton from specific groups of plants, animals, and bacteria. So it means that the chemical compounds whose source origin is known. So once it means that once you know the chemical compounds, right, that exist in the crude oil, right, you will ultimately know the source of the origins of the oil, whether it come from the environment of marine, lacustrine, or terrestrial. Okay, So these are the basic informations that biomarker analysis or biomarker studies can provide on the information of the organic matter input and pollution environment, and then correlations of oil source or oil correlations, maturations, and biodegradation process. Okay, so the process that commonly occur in biomarker to form petroleum, right, will involve the enzymes control condensations, which microbes use their enzyme to degrade the biopolymer into simple monomer, or polymerizations of isoprenes, which it became larger molecule. Okay, so these are the example of the biomarker in a geological understanding. Okay, so you may read through the tables, right? And the biomarker, the understanding of the biomarker um, will later you will learn in Silo 3. Okay, so these are the source rock parameters, right? That you will learn later in Silo 3. Okay, so this is also part of the presentations that you're going to present from the groups. Okay, so I will go further details, right, of the source rock parameters in CO3. Okay, next you will learn about the catalysis process of the petroleum generation. So this is the second stage of maturation, right? Where it's involve the thermal degradations of corrosions to petroleum that involve reactions of organic matter at high temperature at a greater depth. So basically there would be a pronounced of increasing temperature from 50 to 200 degrees Celsius, in which these stages, right, it will cause the corrosion to thermally decompose to bitumen, to oil, condensate, and gas. Okay, so bitumen here refers to the non-volatile organic matter that's soluble in organic solvent that form during initial heating, right? And the residue here is the non-volatile portions of corrosion and bitumen that remains after maximum heating in laboratory or under natural conditions. Okay, during this stage, there will be two stratigraphic window of maturations. Okay, so one is the oil window. Okay, that is the depth interval in which a petroleum source rock generates and expels most of its oil, and the temperature that the oil windows involved is within the 60 degrees centigrade to 160 centigrades. Okay. Meanwhile, the gas window, okay, is the depth interval in which a petroleum source rock generates and expels most of its oil. Okay, so the temperature range is between 100 to 200 degrees Celsius. Okay, so you have to remember that post-mature for oil window is the mature for the gas window. Okay, next is the last stage of the maturation level, that is involve the metagenesis process. So what is metagenesis process? This is the last stage of significant thermal alterations of organic matter, with the small amounts of methane is formed and remaining organic matter is converted to pyrobitumen. So this is a zone of higher temperature from 200 to 250 degrees Celsius. Okay, so what happened in this stage? There are processes involved. Okay, first, methane generations diminishes and graphitic structure begins to form. Okay, and then the atomic ratios of hydrogens to carbon ratios of the hydrogen will become lesser, that is less than 0.4, right? And it also involves the high temperature process, right? That is actually the beginning of the metamorphism stage. Okay, all right, so this is the summary, okay, of the generations of source rock, generations of the petroleum, okay, from the dead living organism, and involve three different level of maturations processes, that is diagenesis, catagenesis, and metagenesis. Okay, okay, as a summary again, the hydrogen content exists in the hydrogen will be used to evaluate the quality of the petroleum product. Okay, and the quantity of the organic carbon content is used to evaluate the source rock richness. Okay, all right. So you can see here for the TOC value, right? You can classify the source rock as a potential source rock if the carbon content in the sediment or rock more than 0.5%. Okay, below then this value means that the source rock is not considered to be as a potential source rock. Okay, so you can see here the H by C and O by C ratios that from the Venn Caravelin diagram, right? It illustrated, or it illustrates the four types of the corrosion at different maturation level. Okay, the corrosion type here subjected to the increasing in temperature and pressure. Okay, you can see that the temperature and pressure increase towards the lower left corner. So the boundary of the color represent the thermal maturity that determined by the vitrinite reflectance. Okay, you can see that the green one is immature, the blue one is mature, and the black one is post-mature. Okay, for the diagenesis process in the green area here, right, it represents the immature corrosions that have not yet generated the petroleum. So moving to the left, okay, along the pathway, it will cause the corrosion to enter the oil generations by the high temperature, and this source rock will become a mature source rock during catagenesis stage. So as the oil generation approaches a peak less than 0.9 of H by C ratio, the gas generation started to dominate. So as the gas formed, right, part of the remaining oil and condensate will be expelled as usual from the source rock, and any hydrocarbons that is still remaining in the source rock will then crack further to gas, and the last product will be the dry hydrocarbon gas of methane. So good to excellent TOC, right, will have a more than 0.25 H by C ratio and serve as the best oil source during catagenesis stage, while type 2 corrosion will have H by C ratio between 1 to 1.5 and will moderately produce oil-prone and gas-prone during the ketogenesis stage. And the type 3 collagen will have less than 1.0 H by C ratio, okay, value, and serve as the best gas-prone during ketogenesis stage. And residual organic matter here is formed by the remains of oil in the source rock that do not undergo secondary cracking to the gas. So thus it will form the pyrobitumen and later into graphite during the metagenesis stage. Okay, so this is the end of the part 1 ClO2. So you will have to watch another videos of the continuations of the part 2 ClO2. Alright, thank you.